Alright, hi guys. I know you're all away, so I'm going to do this for you remotely. You're going to watch this. Welcome. Welcome to my digital classroom. You might need to turn your volume up. And I'm going to make mistakes. It's the first time I've done it, so stick with me. Okay. This is the homework you guys were given at the end of last week's class. So, we did a prac, and we looked at different activities that gave different responses to exercise. So my name is Mr. Bottrell. The first activity I did was with a frisbee. Okay? So I'm going to write in here, frisbee. Before the activity I took some measurements of what my responses to exercise were. Because I wasn't doing anything, my responses would be really low. So I'm going to write my heart rate. My heart rate equaled, let's say my heart rate was 50 beats per minute, BPM. Another one I could have done would be respiratory rate. My respiratory rate equaled, let's say I'm pretty normal, I'm pretty average, let's say I was doing 12 breaths per minute. That's my respiratory rate. And another one I could have done could be my, what else did we take? We took blood, our oxygen content, our SpO2. And my SpO2 would have been 98. And then I started doing the activity. I played from a frisbee, I threw the frisbee back and forth, and in the middle of the activity I measured my responses to activity again. My heart rate would have gone up slightly. My heart rate would be elevated maybe to 80 beats a minute. My respiratory rate must go up because my heart rate has gone up. And I can't fake respiratory rate and heart rate as a response to exercise. So let's say my respiration went up to 18. I'm now breathing at 18 breaths in a minute. And my SpO2, my volume of saturation of oxygen, minus, I'm going to tell you it would have stayed at 98. After the activity, I've finished, I'm not doing anything more, and I sit down and I have a rest. My heart rate would drop. Let's say it went down to 60. My respiratory rate would have dropped also. It would have dropped because my heart rate has dropped. My body doesn't need as much oxygen after the activity, so it's gone down to, let's say, 15. And my SpO2, my volume of saturated oxygen in my blood, what do you know? It stayed the same. I then went and did another activity. And the activity this time was that we played a game of mat ball. No, we didn't. No, we didn't. We did suicides, didn't we? Suicide runs. We went back and forth from the goal square up to different cones at 100% intensity. We sprinted. But before the activity, when I was just waiting, my heart rate wasn't that high. My heart rate might have been 60 beats per minute. My respiratory rate, I haven't done anything, so it's pretty low. And my SpO2 was 98. So I haven't done anything. I'm just getting told the rules. I'm getting told what I've got to do. We start doing the activity. We're doing the suicides. We're running back and forth. Can I measure my results during the activity? No. I can't stop and take my respiratory rate and my heart rate. Not applicable. In other words, it doesn't matter because I can't do it. I'm doing suicides. I can't stop. and do these things. So I've got to wait until after the activity. And after the activity, I take my heart rate, and my heart rate is really high because my activity was really high intensity, it was really fast. So my heart rate has gone up to 175. My respiratory rate, if my heart rate has gone to 175 beats a minute, my respiratory rate would have gone very high as well. So let's say my respiratory rate went to 25. I'm breathing really hard, really fast. My SpO2, my volume of saturated oxygen, might have gone to 99 millimoles. And then the last activity we did was a game. We played a game of mat ball. And with mat ball, before the activity, my heart rate, of course, because I haven't done anything before the activity, is quite low. Beats per minute. My respiratory rate, of course, it's in line with my heart rate. Let's say my respiratory rate was 14. Let's say it's a little bit higher because of this activity here. I just finished my activity, so it's a little bit higher. And my SpO2, 98. I play the game. In the middle of the game, I stop and I measure my heart rate. And what do you know? My heart rate's up at 120 beats a minute. My respiratory rate, in line with my heart rate, has also gone up, but it's not that high, it's at 20 breaths per minute. And my SpO2, my volume of saturated oxygen, is at 98. I finish the activity, I play for another 3 or 4 minutes in a team game. Heart rate's 130, respiratory rate is 21, and my SpO2, my volume of saturated oxygen, is at 99. Okay, what does all this mean? The patterns is what we're looking for. The Frisbee activity was quite low intensity. So if this here, if the suicides, if we said that they were 100% intensity, they were the hardest of all, the Frisbee might have been 60% intensity, and the mat ball might have been 80% intensity. Intensity is a measure of how hard something is to do. When we look at our results of our heart rate, our respiratory rate, and our SpO2, which ones are the lowest? Which ones are the lowest? Well, if I can change my colour of my pen to a highlighter, let me see. Cool. The ones that are lowest are these ones. They're all quite low for an activity. Does that make sense? Why are they lowest? They're lowest because it's a low intensity activity. Which ones are the highest? Which have the highest results? Well, if this is 100% over here, it makes sense that, yes, these results are the highest. Where my heart rate was 125 beats a minute, 175 beats a minute, my respiratory rate was 25, so I'm breathing harder than any other time. And my SpO2 is at 99% of maximum because my body is requiring more oxygen, so it absorbs more oxygen. I can't trick it. It only does it if it needs it. And so therefore it also makes sense that in the middle we have this 80% of maximum intensity with mat ball gives us results that are about the same. They're nowhere near as intense as the suicides, but they're more intense than the frisbee. What does all this mean to us? Well, the idea of the activity was to show you this, that as intensity increases, so does an increase in heart rate and respiratory rate. They are linear. They go up together at the same rate. If we were to draw a graph of time over intensity, percentage of intensity, what would the graph look like? It would go up. If that was the red one was heart rate, and the green one, ooh, sorry, I don't know what that is. Okay, I'm back with you. The green one would go up at the same rate in a similar pattern, and the green one could be respiratory rate. So intensity of activity is linear with heart rate and respiratory rate. Here endeth the lesson. Hope it makes sense.